Dark matter, dark energy. We don't know what dark matter is. It's 85% of the gravity of the universe is dark matter. Is something we don't know what it is. So we just call it dark matter. We don't know what. The universe has some pressure in the vacuum that's making it accelerate in its expansion against the wishes of gravity. We don't know what that is either. We call that dark energy. This sounds like we know something. We don't. I could call this Fred and Wilma, okay? It doesn't matter. We are dumb stupid about what these two things are, all right? Now, normally that's not a problem, like, until you look at this chart, okay? So everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So according to this chart, we are 96% stupid in the universe. You're happy about that, apparently. I don't know what that means, you know. Are you applauding my honesty? Are you applauding, you're celebrating the stupidity of our species? We got the Big Bang. That's been going for a while. Now, not everybody's happy with the Big Bang. You found this billboard. So apparently, God isn't happy with the Big Bang. I would have thought he'd be totally cool with it, but apparently not. I found this bumper sticker in New Mexico. The Big Bang Theory. God spoke, bang, it happens. This one is okay with the Big Bang, but that God did the Big Bang. So people are still trying to wrestle with this. Here's what we know. This is the entire universe in one slide. Quantum fluctuations, birth, an entire explosion, rapid expansion, we call it inflation. That's an idea that came about in the 1970s when there was inflation, severe inflation in our economy. So the word had a lot of currency back then. Now it's like you're inflating a tire, like what are you doing, you know? There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first stars. We call it the dark ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later. And that telescope, we can't see the whole name, it's called WMAP, Wilkinson Microwave Anisotropy Probe. They clearly didn't want anyone to pronounce that or remember it. I would just call it the Big Bang Machine. That made this measurement. And so it's a pretty coherent picture that we have of the origin of the universe. And here's that map that the space probe shown. And so this is a record of the earliest moments of the universe. And it tells us what the universe was up to. And data agree, we're all pretty happy with this, and we're kind of moving on. The Big Bang, by the way, could fit into a larger story. For example, the multiverse. Big Bang is probably not the whole story. It's probably a piece of a bigger story. So maybe there are multiple Big Bangs. This would give us the multiverse. We don't have data for this, but we have good theoretical and philosophical reasons to think that a multiverse exists. How do you even draw that? Because you need higher dimensions for it. So here are these, each of these bubbles is a universe coming in and out of existence, and we're just one of them. And who knows how many universes there would be. This is very kind of spooky looking, but these are fluctuations, quantum fluctuations in the universe that spawn entire other universes. So it's an intriguing direction. So put this word in your vocabulary and watch it show up in news accounts. It may be that the dark matter is not matter at all. It's the gravity from ordinary matter from a nearby other universe in the multiverse. whose gravitational influence we feel. And here we are, saying, ooh, we have a mysterious gravity, call it dark matter. Really, it's just ordinary matter doing its thing in an adjacent universe. So a multiverse can give you some predictive power, but it's really out there right now, and so we need to give it some room to. Here we go. Boom, boom, weightless astronauts left Earth's gravity. North Star is the brightest. In the dark night, you can make out millions of stars. Total solar eclipses are rare. Days get longer in the summer and shorter in the winter. High noon, the sun's directly overhead. Sun rises in the east and sets in the west. The moon comes out at night. And what all these have in common is that they're all false. Every one of these is just false. But we've heard them and we retell them. And we retell them because we assume they're true, because either you want them to be true or they feel like they should be true, but they're not. They're not. The first one, what goes up must come down. That's true if you're just human, right? If you're just flesh, whatever you throw up, it comes back. That's kind of life experience. However, we've got like golf balls on the moon that are never coming back to Earth. Stuff that went to the moon reached escape velocity from Earth. There is a speed with which you can throw things, so they'll never come back to Earth, ever. Ever. We have 5 spacecraft that have achieved that speed in the history of the space program. Pioneer 10 and 11, Voyager 1 and 2, and the New Horizons mission. So good. So you hit escape velocity, it never comes back, ever. It'll go to the edge of the universe and never look back to Earth. So it's just false. The sun is not a yellow star. The sun is white, right?